men, and I use the term loosely. Hey, we're here today to finish the machining on the crankcase at the giant hole where the transmission goes in. Uh, just FYI, I did buy some brazed iron carbides on Amazon, of course, and as delivered, this one here on the right, there's no relief angle whatsoever on the carbide. This one is the one I'm going to use today, and I did grind a relief angle on it. And I did use a square, a little fixture I made to hold it in the up against the grinding wheel correctly. So this does have a little relief ground into it on this face and this face. This one has none. So if you buy any of these things, don't expect them to work out of the box. You'll need to do a little grinding on them to get them to work. And this brazed in carbide is the one I had been using to. As you can see, it's quite long, and I went with one considerably shorter to try to help me clean up the finish in there. This one I'm going to use today later on because I need to create a round, flat face on the right hand side of the crankshaft around the countershaft bearing bore for the countershaft low gear to thrust against. So I used a little fixture on this one too, and I squared off nearly exactly this face here. When it hits the bottom of the hole, it should create a flat bottomed hole, which is what I want, and that will be where the thrust washer rides for the countershaft. One other thing to note, I fucked up, and I know you won't be able to believe this, but I fucked up. I misread the micrometer when I started boring the hole. And remember at that video I said I'm about to do something that I hope I don't regret. This is kind of one of those things that I thought could happen, but you know, I would have hoped that I could read a micrometer by now, but apparently I misread the micrometer, and the hole right now is just about 6 or 7 thousandths smaller than it needs to be. So when I go back in there to work on this thing, I need to really just skim off a bare sliver of metal, 3 thousandths each side of the hole, more or less. So it's going to be a little bit tricky, but I have every faith in myself that I could pull it off without jacking it up. All right, we're going to go in there a little bit, and I'm just going to feed a little bit in by hand just to see how it goes, and let's see what happens. All right, I'm just barely scratching it. I went in about 1/8 of an inch, and it looks good, so I'm going to go ahead and do a full pass here. Ooh, that feels real good. Yeah, I'm happy with that. All right, let's check the size. All right, I'm at 874.874. I want to end up at 0.877. So we're going to shove out another thou here. Okay, that should be about 2 thousandths of an inch. One of you viewers suggested a little WD-40. Nice. All right, I'm very close. You know, I think that's going to be just right. I think that's going to be just about perfect. So we're going to call that good right there. All right, I touched off on this surface here, which is unmolested, and set the height of the mill. So the z-axis is like down, the DRO is zeroed, and I'm going to flatten out this part here. It doesn't look like I'm going to even touch this part here, but this is where the bolt goes. This is where all the stress is going to be concentrated. So we're going to flatten that out. All right, time to take the case off and see if I'm anywhere near the ballpark for the shaft. And there you have it. The camera is almost, but not quite, straight on. So, it may look a little bit off, but when you look at it, straight on, dead nuts, right down the middle, it looks exactly centered. So, very happy with that. So, this part of the operation is successful. We're going to go into the other side of this case and flatten out the area around here to give the thrust washer somewhere flat to land. Oh, and this is a countershaft stuck in there right now, an old countershaft. I got the right-hand case clamped down to the mill bed. I centered the mill over the countershaft bearing bore with my coax indicator, and I'll just show you that real quick right now. So that's the hole I just bored, and I'm centered over that hole, and I'll show you why. Okay, because of the way this is positioned on the mill, it's hard to get a good angle on it. But anyway, see this raised boss over here? This is too fat. It's too thick. It needs to be brought down. And the problem with it right now is if I were to put these cases together and put a countershaft in there, it's not going to be able to turn. It's going to bind up because this is sticking up too far. So I have another case, and I measured the distance from the mating surface to the corresponding area on the other case, and I'm going to use that boring bar that I had flattened on one end to embiggen this area. And I need an area for the thrust washer that goes in here to sit flat upon the crankcase. So we're going to create that now. I've measured down from the mating surface plus the thickness of this little ruler over here with a depth gauge on this case and another case that I have, and have determined that I need to remove 1/8 of an inch from that boss that's sticking up inside there that's, proud of the surface. So we're going to set up the boring bar on the mill. The hole is centered under the mill, and we're going to embiggen that, and it's got to be a sufficient diameter so that the whole of this gear could sit on it if need be. So that's next. All right, I've taken one pass with my boring bar, and I've cleaned out this little area in here. I moved the boring bar out, another 40 thou or whatever, and I'm about to take another pass. I checked the depth of this compared to the other crankcase that I have, and this is about 10 thousandths deeper in, so I'm a little bit deeper than the other case would lead me to believe that I need to be. But that's okay because, there's the countershaft low gear thrust washers, and then there is the countershaft thrust washers. So there's several washers, and I'll show you those later on, how this works, that can be manipulated to get the clearance you want. So this is looking pretty good. I'm pretty happy with this. So it's a very difficult camera angle to get into. You probably can't see shit, can you? Let me see. I don't know if that'll help any or not, but it's deep down in a hole. There's a lot of shadows. I might show you a little bit of this, but the long and the short of it was I'm going down 125 thousandths, 0.125, and that should get me where I need to be. So let's fire the mill up, and I'll take one more pass and show you how it's working. I'm using the hand dial to crank it down. I've only got to go 125, and I don't want to use the auto feed. I'm just dialing this in by hand. So I think that's going to work just fine. Let's go for one more pass at it. All right, maybe I'll show you two passes. That's working surprisingly well. I've done this, well, on other jobs that I've done on this Transboss, I've just used an end mill, and you can't make a circle with an end mill accurately. Cranking both handles at the same time, X and Y to maneuver it around. So I wanted to try to get a perfect circle there today, and it's working well. You may wonder why I'm using a long boring bar, and that's because I wanted the boring head outside the crankcase. I didn't want any chance of the boring head smashing into the crankcase. Well, it's time to see whether this is going to work or not. I'm going to put a little of the green Loctite on there. Probably don't need it really, but putting it on there anyway. That felt pretty good. We're going to flip this over. Going to wipe that Loctite off so it doesn't get into the rollers. Well, that's just exactly perfect over there. You could see this area here that I flattened out. Happy with that. Now, the other thing that happens with these that really is a bummer is if the interference fit is too tight, the bearing closes up and the shaft won't go in and rotate. Goes in and rotates nicely. Okay, so that's good. So let's see. Let's see if it all lines up more or less. Okay, before I see whether or not the whole mess fits and rotates, let's talk about the countershaft low gear. This is the gear Well, this wasn't the gear, but it was just like the gear that would have been in there. Speedo drive, no speedo drive. So the later ones with the speedo that drives off the front wheel use this gear because there's no longer room in the trans case on the later models because they reinforced it quite a bit, and there's no room for the spiral gear anymore. So when the owner puts it back together again, he's either going to A, have to get one of these, or B, this is pressed onto a flange. You could unpress it off of there, and then you could grind the flange off to turn this gear into this gear. That'll work. Now, a caveat is these gears are a little bit different on the back side. This gear has one of these spacers. One. This gear, and I forget the breakover, 74 maybe, this gear has two of these spacers in it, and these come in varying widths. So you could use these spacers to control to an extent how much of this gear engages to the countershaft third gear or not by varying the width of these things. And of course, when you vary the width of these things, it pushes the gear right or left, depending on how much stack up you got over here. Well, that changes the thickness of the thrust washer that goes in here. So you're balancing all these clearances. And when I was cutting that relief for this gear and making the thrust face, I wasn't really concerned. I wasn't really particularly trying to be extremely accurate because this is adjustable a couple of 2 or 3 different ways. So you should be able to figure out your combination of spacers that go in here and then your thrust washer that goes over here and make it work. You may have to do some finagling, but it should all be doable. My main concern was that the gear had some free play in it to slide back and forth, because if I didn't machine enough of that repair section out of there, this was going to bind on the crankcase and it wouldn't rotate, or would rotate very difficultly and would cause a problem. So anyway, gears, thrust washers, spacers, you have to, you have to work this all together and be careful when you put it together. I'll give you kind of a flyby of the finished repairs on the outside. I don't remember whether they showed any of this or not, but the plug, of course, on the bottom of the crankcase was stripped out, and they crack right between the edge, the hole in the edge of the case. That got all welded in, built up with weld. I mill the sealing surface flat, and while it's up in the mill, I drill and tap the hole in it so that the plug is square to the sealing surface. And lately I've been using these soft aluminum washers. I've used copper in the past, but actually copper ones have gotten really pretty expensive, and the aluminum ones are cheaper. Back here, the repair section didn't quite go far enough. It could have been another ½ an inch longer. So several beads put in here to build this up and close that gap. Welded across the bottom over here. Same routine over here. Filled it all up with weld. Milled it all flat. While I had it in the mill, I drilled and tapped the hole so that it would be perpendicular to the sealing surface. And once again, the soft aluminum sealing washer. And then, of course, welded around here, up the back. All this welding went pretty smoothly. And then, of course, the weld across here. This should be a good, solid repair for this owner. Should hold her very well unless he misses that first to second shift. But otherwise should be pretty well. Oh, and milled off this part of the repair section, so it's even with this part of the case over here. I did not drill the hole for the sprocket cover because I didn't have another sprocket cover laying around to line it up with, so he's going to have to do that himself. But I figure if he's in this deep, he should be able to handle drilling and tapping a hole. bearing, nice interference fit on here, fit very well. A little green Loctite on there. This thing is not going to come out easily, that's for sure. I did a test fit on the shaft in there. Fits good. Anyway, this is ready to go in a box and get shipped out of here. All right, then. So, let me tell you how I fucked up again. It's getting kind of late Saturday night, and I'm putting this video together for, of course, Sunday morning, because that's when I've gotten in the habit of putting them out. And I'm going through the editing, and I realize that the shots of the most important thing, that being, you know, whether or not the shaft is going to rotate and have end play, are missing. And as I go through the video, I realized that the locks on the camera tripod must not have been set, and the camera drifted off and started pointing the other direction while I was doing this. So I already had this thing boxed up, ready to go, sealed up, weighed the whole shot, and I decided, you know, this whole thing was, you know, you need to see this because this is the part that kind of matters. And the irony of it is that when I test the end play and the rotation, you can't really see anything because it's inside the case. But anyway, I decided to open the box up, do it over again. So I have, once again, a countershaft. I have the countershaft low gear, a couple of random countershaft thrust washers. Well, properly termed countershaft low gear thrust washers, not to be confused with the countershaft thrust washer that goes in here. So anyway, we've got a countershaft stacked up, and we could put the case together. You know, and I just went into a panic because I'm trying to fit the cases together and they won't go together. And I thought, what the fuck? I just checked these earlier. Oh, yesterday afternoon, whatever day it was, when I got it finished, and they worked fine. So I remembered I had put a plug in this bearing to protect it. Thank God. Anyway, let's see if they fit now. And we're going to put a bolt in here. I'm not going to put all the bolts in. I'm just going to put a couple of bolts in. We'll put a bolt in here. Snug her up. And we'll put a bolt in here and snug it up. And I guess we'll put one in here. So that should put a even force on it pretty much. All right, so the cases are bolted together. There's a countershaft in there, and the countershaft has got a gear on it. And I stick a finger in this hole, and I could feel the countershaft low gear spinning freely. Hear that little clicky clicky? That's the free play in the gear. So, yeah, this could be put together and it should work. But the countershaft low gear spins on the countershaft, so you really don't know if the countershaft rotates. Which is why I have a countershaft drive gear on here, and now I can verify that the countershaft rotates, and I could see the free play on the end of the countershaft over here. So, yeah, this is good. This is going to work just fine. Yeah, so this is done. That's all I got for you. I'm out of here. We'll see you next time. Y'all have a good rest of your day. Men, if you like this channel and this content, The single most important thing you could do to help grow this channel is to hit the subscribe button. I also have new design coffee cups and stickers available. You know, I like the old coffee cups, but I like these new ones even more. Links are included in the description down below. And for those of you who really want to go the extra mile, you could join me on Patreon. Link is also included in the description down below. And to all of you who have watched these videos, I'd like to say thank you. Thank you very much. I really, really do appreciate it. We'll see you next time. Bye.